Hi JSConf, and there are a lot of us here today. I'm a little bit nervous today, not to speak in front of you, but for two other reasons. One is that there was a release this morning of the project that I'm working on at 1 a.m., and I've just turned off Slack, so... And the other is that my boss is in the audience. Jed, raise your hand. Jed doesn't know this yet, but this is actually going to be a pitch for how we should develop our next project. I'd like a little bit of help from everyone towards the end. If I've convinced enough of you that this does seem like a viable way to develop a project, after the talk, could you just go up to Jed and let him know? So I'm going to talk today about modularity and monorepositories. And essentially what I'm going to cover is not whether you should use a monorepository or not, but the ways in which these techniques might be able to help you write better software. I did warn that I had a loud voice. Write better software or write more maintainable software over time. And I'm going to cover it in three phases. The first is I'm going to describe what a monolith looks like. Then I'm going to describe what a monopurpose paradigm looks like. And then I'm going to describe what a monorepository can do for you. And if this is starting to sound like I'm covering off some unbelievable dream, we might get to that point at the end of it. So to begin with, I want to start from the perspective that good architecture is going to cost your company and is going to cost you less over time than bad architecture will. My fiancée, who promises me that she's tuning in to this talk now, is a bricks and mortar architect. And that means she doesn't have the benefit towards the end of a project of being able to go back over the things that they've been working on and fix up anything that doesn't work, like what's on the screen. As software developers, we have that power at any point in the project, time and money constraints providing, to go back over and change anything with very little cost. We should be making sure at the beginning of a project that the decisions we make protect us to make good decisions later on. Not necessarily to get everything right at the beginning, but just to be able to make the right decisions as we move through the project. There's a very famous quote by a chap called Melvin Conway that covers off the way in which you produce solutions compared to the way your organization communicates. If you have one person driving the entire company, you probably have one person or very few people driving the software solutioning as well, and this tends to show up in the way that you produce software. I think this is a very interesting idea, though, for the opposite reason, which is that the way that you produce software can actually change the way your company communicates. If you tend to produce monolithic software, or if you tend to produce very isolated software, you'll also probably have isolated teams, and that means the information inside your company's systems are going to be very isolated. This will lead to things like very small bus factors and dangers when people leave your organization, as well as needing to rely on very small numbers of people to be able to fix any problems that come up. So what does your organization look like? I'm going to cover a little bit about what mine looks like. Like I mentioned, at the moment I work at ThinkMill, and we're a developer consultancy. And what that tends to mean is that we work on a number of different projects at a time, and they're all relatively isolated because different clients means different code bases, and we have individual teams running them. And so a lot of the information is kind of constrained into the system that we're looking at the time. We do the obvious things that NPM gives you to break out that information, as I'm sure everyone does, but it does mean that reusing software in between projects can be a little bit challenging. So let's start with the project that I'm on at the moment. The project that I'm on at the moment is basically just a monolith. And this is not a bad thing. I definitely don't characterize it as a problem. It's often the fastest way to get a solution to market. But it does come with its own set of challenges. The first is that keeping an entire monolith in your head can be pretty challenging. This is a relatively small monolith. It only has about 30,000 lines of code, pure JavaScript code, but 30,000 lines of JavaScript code. So this can be very challenging when you need to make a change, especially if your architecture patterns have evolved quickly over time. Knowing where files are, knowing where functionality is can be very difficult. Similarly, we work on a lot of open source projects. And this can mean that we end up with a smaller subset of small projects and functionality. And we'll see that we break that up into smaller pieces. So we have the individual projects that make up the Keystone project, the large open source project that we maintain. And those break up into smaller pieces, are easily shareable and easily reusable. But shipping these kind of features throughout a system can take a lot of effort and a lot of time. So finally, the thing that I'm here to try and sell Jed specifically on and everyone in general on is a monorepository. That idea that it will bring some kind of value to the business in general is what I'm going to try to focus on. So let's take this mono, and we're going to cover off 3 different ways that a monorepository might be able to help your organization deploy, release, and develop software over time. The first one we're going to focus on is deploying a release. So if we look at the way that a monolithic software structure deploys a release, you just deploy the release. You have a single deploy candidate. There's one piece of software inside your application that goes live, so you deploy it. I'm actually just going to interrupt myself quickly here. Terrible looking slide, and if I'd only asked Sharky for help earlier with the CSS for this demonstration, this would have gone a lot better. So I apologize. So a monolithic structure has a single deploy candidate, and that's what we deploy with. In contrast to that, a monopurpose repository, a monopurpose paradigm rather, is a number of repositories who have a single deploy candidate. In the JavaScript ecosystem, the people who do this the most are people like James Halliday or Sindra Soros, who tend to produce one small package for exactly the feature that they're working on, no matter how related that might be to another package they already have. And this is an example of things like the Unix ecosystem, where you have tools that are meant to do one thing and just do that one thing well. But what you end up with are patterns and projects that are all kind of related, but all very distributed. Whether you remember that you have this project in a different place, whether your documentation and your discovery mechanisms are good enough for your team to remember that these projects exist, these are the challenges that come with a monopurpose organization. And so what we end up with are innovative tools like style guides or individual internal component repositories, or using GitHub descriptions to make discovering these new mechanisms more obvious. Whether we succeed in doing that or not is often down to whether our organization has discovery as a priority inside the organization. Finally, we have a monorepository. And again, although a monorepository is the encapsulation of a number of projects inside one repository, to deploy something like that really should only ever be a line of code. What we end up having is scripting the individual deploys inside the repository, but then kicking them all off in one command. The advantages here are that while you do have this disparate, separate set of steps that occur, you, the developer, only have to do one thing. And that is much less risky than if you have to manually type in 20 or 30 commands. I know that personally I have forgotten to deploy a key piece of infrastructure because I was deploying 15 other pieces of infrastructure and found that out late at night when a deploy didn't work the way that it was meant to. And from that point forward, I've made sure that I try and keep as few moving pieces as part of a deploy process as possible, which is where my interest in this area kind of stems from. Let's take a look at the idea of sharing common functionality. If I ask how many people in the crowd have heard of the DRY principle, don't repeat yourself, basically everyone. This is good. We're JavaScript developers on the most part, and JavaScript gives us such a simple mechanism to extract and share code. We'd be wasting potential if we didn't take advantage of that. But not every project does that out of the box. So if you look at a monolithic structure, by definition, a monolithic structure will not share code out of the box, because that's what a monolith is. It's all of your code encapsulated in a single repository. As soon as you start to move to more of a modular strategy, you have the ability to break out as small a function as you like, and even make the entire JavaScript ecosystem dependent on that one small function, as we all found out a couple of months ago. Similarly, with a monorepository, you have the ability to have that same small function take the forefront of your application, take all of the functionality just related to that one module, extract it and deploy it as an individual NPM module, but still retain the ability to edit it inside the larger context of your project. And what that gives you is the ability to see the context of your entire application, how it relates to that single module. It's a very powerful paradigm. The final thing that I'm going to discuss in the context of these 3 repository patterns is the idea of making atomic changes to shared dependencies. So what we're going to look at with this one is, when I have to make a change to something in my ecosystem, how do I roll that change out through all of my projects? In the case of a monolith, again, you have a single deploy. You have no way to roll out changes to a distributed ecosystem because your code is just related to your single deploy candidate. You might have a couple of steps that deploy multiple monoliths at a time, but you have no way to encapsulate that inside one monolithic structure. For a mono-purpose paradigm, where you have lots of NPM modules individually, again, there's no real way to encapsulate that information inside one repository, unless that one repository's only responsibility is deploying all of your other repositories. And at that point, you're back to having, again, how do I keep that one up to date? How do I know that that refers to everything that is there? Finally, we have a monorepository. And because you have the majority of your code inside this one structure, making a deploy or making a release is as much as adding the files, committing them atomically, creating a pull request, having the pull request reviewed, merging it, and you're finished. At that point, if you have automatic CI integration and CD integration, you can deploy your code automatically. If you don't, then you have your scripts that you run manually at the tail end of a release, and you run those. But you can see a snapshot in time at every step that you change something in your application, and you can follow those snapshots back through history and see, this is the point that we made the header green because we thought it would give us 25% more revenue. These snapshots of history will give you the ability to see throughout time the changes, not just to the individual modules and try and make them match up, but to your entire ecosystem, your entire company or organization's projects. All of their history is encapsulated and shared in the same place. So in comparison, we can see that a monolithic structure is very strong at deploying its individual release candidate. But it's a little bit less able to share that functionality across an ecosystem, and it doesn't have the ability to know about the larger context that it runs in. Similarly, a monopurpose or a modular structure does not have the ability to know about its larger ecosystem. And while it shares functionality very well, deploying those individual bits of functionality can be a little bit challenging. Finally, if we look at a monorepository, what we end up with is the ability to deploy these changes atomically, to share functionality across our entire system, and to make atomic changes throughout that system as we go. So this is the paradigm that I'm going to describe. Finally, we have this concept of a monorepository. And what does that mean, and what does that look like? So that's what I'm going to demonstrate now. And depending on how I run for time, I might also live demonstrate it. We'll see what happens. So a brief note before I begin getting into what the code actually looks like. This is not a talk on Lerna. Anyone who has heard of Lerna or used Lerna in the audience, this is not that talk. Lerna is a tool for managing monorepositories, but I'm not going to delve too deeply into how it does it. There are a number of options in this space, Lerna just being one of them. And if anyone is interested in that idea after this talk, I definitely encourage you to have a look at these three options and to see which one makes sense. Lerna, Formidable Labs' builder, is another one. Formidable Labs, the open source division run by, I think, Ken Wheeler. And finally, there's a pattern called the, I think, ALA pattern. And the idea here is that the way that Node's module resolution algorithm works, you can actually just store all of your source code inside a folder called Node Modules, and it will resolve up and down the Node Modules tree and find everything that you need. It's quite a cool trick. And if you look at the PouchDB repository, that has this implementation running at the moment. So you're definitely free to do it yourself, but your mileage might vary. And the amount of code that you end up writing that rebuilds existing functionality somewhere else is definitely a risk. And at the same time, breaking out of something like Lerna to a different pattern is not a big deal. It's very easy to move from one of these to the other. So let's look at what the setup for a monorepository looks like. We're going to cover off starting a brand new project. We've got our first day working at the new startup, and we have to create an entirely new repository and an entirely new structure. So we run Lerna init. And what Lerna init does is initialize a repository, initialize a Git repository, create some files, and create a packages folder. This is the end result of creating your first monorepository. I've created two folders inside this repository, a demo button and a demo header. The naming of these folders just corresponds to the name of the package JSON inside the monorepository. And that's what this looks like. So you can see here that I've scoped the package JSON to an organization name. That's freely available. And I've also declared inside my header that I rely on my button component. When I start working on this, immediately I'll be able to make changes to either of them and see those changes reflected where they're used. So once I've declared my first few projects, I run Lerna Bootstrap, and it symlinks together all of the dependencies. What it actually does under the hood is build a great dependency map of all the different things that rely on all the other different things. It will install anything that you don't have inside your monorepository, and it will symlink everything that you do. So what that means is that rather than installing from npm some candidate, or instead of running npm link manually yourself to set up these links, instead Lerna just takes care of all of that for you. Finally, that's what we have here. So we see we have the same two folders, but we see that inside the header component, we have a direct symlink to the button component. At this point, any changes that I make to the button component folder will be reflected in what the header component sees when it requires the button. So this is all kind of architecture-y and DevOps-y. Let's look at some actual JavaScript code. Well, not yet. Because it's JavaScript, we now install Babel and Babel ES 2015 and Babel React, and we run ESLint, and we install Mocker, and we install React. The same kind of stuff that we would do for the beginning of every project. But because we're doing this inside a monorepository context, our dev dependencies can be shared across our entire application. So what that means is you only install these things once at the top level of the monorepository, and you can reuse them everywhere inside the application. So this is quite good because has anyone gone and gotten a coffee while waiting for an npm install to resolve? Yeah, right? So with this practice, you run npm install once, you have all of your dev dependencies waiting there for you, and to start a new project, you just put the actual source code down. You don't have to set up anything other than what you already have. So what we end up with now inside each of our components is a Babel RC in case they have anything particularly peculiar about how they need to render JavaScript code. And we have the exact same Lerna structure, the exact same monorepository structure. So if we look inside a component, in this circumstance, they're just ordinary React components, but this is not a React paradigm. This works for all ordinary JavaScript code. But what we have at the top there is a ES6 modular import. Import button from organization scope / package name. We're not walking relative paths. We're not like going, cool, on the file system, if I'm in development mode, find the file here, otherwise use the actual file from npm. We're not doing anything different than what we actually do in production. Instead, what we have is just a call to a button component. And because we're symlinked inside node modules, it knows exactly where and how to find that component. And as we make changes to the button component, they'll automatically show up here. I'm not going to go too deep into the content on this slide. The reason why I have that in the presentation is just to highlight that everything that you can do normally inside an npm component, you can do as part of a monorepository. Linting, testing, compilation, watching, hot reloading, all of that works very simply. You just essentially bring it up one context to run from the root of your project. And with Lerna specifically, or with Bash generically, scoping those commands to a particular project is achievable. So it gives you the opportunity, depending on how comfortable you are with shell scripting, to either take this into your own hands or to use an existing project that's already solved these problems. So a big part of what I care about is developers. And the developer experience is something that I've spent a lot of time working on and working with and trying to figure out the right nice patterns to make developing software enjoyable. And what I'm going to show on the screen here is a project called Storybook by Kadira. Essentially what Storybook is an encapsulation of a living style guide for your application. All of those components that are sitting inside my packages folder as separate npm modules are required by the Storybook application, and I can use that to render them with props in the specific ways that they're used. Now, ordinarily, this works really well inside a monolithic structure, where all of your components are just files inside the same tree. But if you envisage having a modular structure where all of your files are in separate parts of your file system, having a project that integrates all of these things together is now another module that you have to maintain. You have another area of source code with another project that requires these files and another project that has to make sure that they're all at the same version or at the right version. Instead, with this system, inside a monorepository, at the root of the application, it just walks the tree and finds all of the places that a story is declared and imports it. So when you add a new project into the monorepository, you add a new story, it's automatically picked up by Storybook, and it shows up in the browser when you load the story application. What you can see on the screen, what's probably played a couple of times now, is hot reloading of the changes that you make across the module. those occur not only across the module that you're looking at if I make a change to the button component, but as we'll see in a slide or two, that they also occur for anything that depends on that button, which means you see in real-time changes, not just to the ecosystem that you're mutating, but to anything that uses that module inside your entire application. Rather than having the concept of work on a module, publish it, integrate it into something, see if you broke anything, come back, try it again, publish it, or deprecate it, or whatever you're going to do. And instead of having to manually go around with an NPM module fix or an NPM link strategy to try and get things to integrate nicely together, instead what we end up with is a way to automatically see these changes propagate throughout our system. So this is quite a nice paradigm. It's quite a nice way to make these changes to our software. So let's think about making a change then. So we come in the morning, and the product owner has said, we love the button. We love it a lot. Big fans of the button. But it's just a default button. We'd like to give it some styling. We'd like it to look individual. Can we change the button? OK? So we come into our component. We come into our text editor, and we add the styles. And we see the change automatically reflected in the button. But we also see the change automatically reflected wherever the button is used. So we have here a header component that also uses the button component. These are separate NPM modules. And when you make the change to the source code for the button, it automatically is picked up and reflected in the source code for the NPM module. And vice versa. As you take the change away, the new NPM module, the header NPM module is reflective of that change. So far I've just shown front-end integration of this. Is this only for front-end JavaScript, or is this only useful for integrating front-end components? Of course, the answer is no. Because it's just ordinary JavaScript, and it's just taking advantage of the ordinary way that JavaScript requires work, using this with a back-end functionality is the same process. So here we have a simple Express server. Well, simple, it's using Webpack and Webpack middleware and a bunch of other plugins to make it work, so simple. But what we end up with is the ability to create a front-end component that is just specific to this server, in this case, a landing page for our startup application. But that landing page consumes the modules that we have elsewhere in the ecosystem. So when we make a change, and we can see here, again, the storybook showing us all the different states that we might be in with our components. When we make a change to that component, we can see it reflected in the actual server code, and it picks it up in real time as well. So whenever you make a change to any of your individual components, not only can you see them live reflected in the actual component render, you can see them in the integration renders, and you can also see them in the full page renders of your servers that are part of the monorepository. You have full end-to-end integration of all of your components throughout your system. And that's reflected here is the deploy strategy. I'm not going to go too deeply into this because it's very individual to Lerna, but the idea is that you can deploy these things at independent versions because your NPM version is held separate from your repository state. So if you have a minor patch for one component and a major bump for another component, you can do that separately inside the same Git repository and push them out as part of the same commit. It's still atomic, but you just have that separation of versioning separate from the fact that they happen to be used together at that step. So this probably doesn't look very different from how people are working now. And that's a good thing. Basically, the benefit here is not that this will revolutionize or make a radical change to the way that you develop software now. Instead, the idea here is that with these practices, you're able to introduce small developer experience tweaks that will make your life a little bit easier. Whether you take away from this that having things integrated together end-to-end at the time that you're developing is a benefit, or whether it's that being able to deploy releases atomically is a benefit, all of these things are small wins that we can make to make our lives as developers easier. The other part to take away from this is that it doesn't require a massive change. It's something that you can integrate into your organization gradually, and you don't have to buy entirely in one go. So there are two paths that you can approach this from. There's the path where you come at it from an existing monolithic structure, where you can say, cool, all of my code is in one repository, but it's all in one NPM module or one server. How do I break it out? And from that point of view, all that you have to do with that is take the code that you have inside your monolithic structure, extract out just a part of it that is going to make sense as an NPM module, and put both your monolithic structure and that NPM module inside one monorepository, and then keep developing your monolithic structure as you normally would. And then the next time that you come across a small change that would make sense as an NPM module, extract it out of the monolith into a small NPM component, bring that out into your monorepository structure, and you kind of continue down that vein, slowly making small changes. The opposite approach works as well. If you're coming at this from a large distributed system, like a large distributed set of front-end components, all you really have to do is pick one as the starting point for your monorepository, put it as the only package in your monorepository, and start developing against it. When you next come to making a change to something, bring that into the monorepository as well. So you can gradually apply these patterns as you go. And breaking out of these patterns is also relatively straightforward. What you have to do to break out of the pattern is to take the modules that are inside the monorepository into their own folder, initialize them as Git repositories, and you can continue deploying them to the same NPM target that you were before. So everything is great now. Well, not necessarily. There are a couple of caveats that I want to cover. The first is that your Git checkouts will definitely slow down. If you visualize having one project's worth of Git, having n projects worth of Git is going to be n times as much Git, simple mathematics. And what that'll mean is that your Git checkouts, your Git clones, and your Git pushes will slow down, especially as all of the developers in your company will be integrating into the same environment. This is not all that dissimilar from having all of your code in separate environments and then having to pull down each of them, and I haven't seen it as a major cost over time, but if you approach Google or Facebook's scale and success, and wouldn't we all like to approach Google and Facebook's scale of success, then that might be a concern that you have to field. You need to get a little bit creative with tagging. What that means is that your releasing process using Git tags can't just be the exact version number. You're going to have to either version it at the module versions and have a couple of tags pointing to that. There are other ways that you can get around this, and there are other processes you can use, but you're probably not going to be able to use the exact same Git tagging process you had before. And finally, build tooling. I covered a couple of ways to approach build tooling, but you are going to have to think about it. JavaScript over the last 2 years has made us all have to think about build tooling in some capacity, even if it's just applying Babel or Browserify or Webpack or something like that. This process will also need you to come up with a way to run your build tooling in a certain way. But the advantage here is that once you've solved that once, you can just use it again, not copying and pasting it, not turning it into an NPM module, just use it as you wrote it in the same place without needing to replicate it into other folders. It also means that when it comes time to update that build tooling, you just can, because everything that's using it is in one place. You don't have to make that change throughout your ecosystem. So I'm going to touch off on one way to approach a middle ground for this, and that's the Zelda project by Feros. This project is a way to take all of your NPM modules that are separate, clone them together, and link them together, in the same way that Lerna or other monorepository builders do, but it won't store them inside the same Git repository. You retain your individual Git repositories, but you can make all the changes in the same way that I was showing before. You don't have the benefit of storing this in source control, and you don't have the benefit of sharing it across your team, but it is a way for you to get used to how the development process works with these tools and see if you are willing to make the buy-in towards changing your process over to this kind of way of doing things. So to recap, monorepositories are a way to kind of take the best of both worlds between modular systems and monolithic systems. They do come with their caveats, but I believe that they will lead to better developer experiences and to a stronger culture of reuse over time in a project rather than rewriting it. And that's that. Thank you very much.